Alright guys, in today's video we're going to be looking at some examples for finding probabilities. Alright, so our first example we're going to be looking at using a tree diagram to find these probabilities. You don't have to use a tree diagram on this problem, it's just one of the ways that you can solve it. Okay, so I got a probability experiment consisting of tossing a coin and we're going to spin the spinner shown. If you're going to notice the spinner has 8 spaces, the numbered 1 through 8, and they're all the equal size. We're going to use a tree diagram to find the probability of 2 events. The first event, event A, is tossing a coin and spinning an odd number. The second event, event B, is tossing a head or spinning a number greater than 3. All right. So in order to do these problems, we first have to see what the sample space is. One of the easiest ways to do that would be to do our tree diagram. So here's our tree diagram with heads and tails, and then 4 heads and tails, each of those has a corresponding set of 8 numbers from the spinner. So you'll see we have 16 total results we could get, all the way from heads and a 1 to tails and an 8 shown there. Now, event A, if you remember, says getting a tails and an odd number. Okay, so we look for the ones that have tails and an odd number. That would be, as shown here, tails in a 1, tails in a 3, tails in 5, or tails in 7. Now, there's 16 total outcomes. 4 of those match our event. So the probability of tossing a tail and spinning an odd number would be 4 out of 16, which simplifies to 1/4, or if you want to put it as a decimal, 0.25. All right, let's look at our second example. We're going to use that same tree diagram. Notice this tree diagram has the same exact 16 possible outcomes that we had before from tossing a coin and spinning that spinner. Now here we're looking for a heads or a number greater than 3. Okay, so if we look at that, we're including all the ones that have a heads because we're looking for a heads or a number greater than 3. Then on the tails side, we're going to include all the numbers greater than 3, 4, 5, 6, 7, and 8. If you total these up, you'll notice that there are 13 out of the 16 satisfy this, which gives us 0.813. Okay, so now let's look at using the fundamental counting principle a little bit on this instead of a tree diagram. All right, so we have our college identification number. It's going to be 8 digits. Remember, the digits are numbers 0 through 9. And we can repeat these, okay? So what's the probability of getting your college identification number when randomly generating 8 digits? Well, first off, each digit can be repeated. So that means there's 10 choices for each of the 8 digits. If we use the fundamental counting principle, then we do 10 times 10 times 10. We do that 8 times, or 10 to the 8th, which gives us 100 million possible identification numbers. Now, we're looking for your specific identification number, so that would be just one of those 100 million. So the probability of getting your ID number randomly would be 1 out of 100 million, or in decimal form there, 0.00000000.